what is the common term? What will the common term be? What's something I can call for short? No? So it's a three-letter word. Acronym, sorry. GCF, the greatest common factor. So when we're factoring on a common term, we're looking for the greatest common factor. So on your examples, you have I, you have double I, you have triple I, right? 4x minus 12, that's I. 5x squared plus 50, that's double I. 3x squared minus 2x, that's triple I, right? Right? Now, if I'm going to factor out factor out a common term, I'm looking for the greatest common factor between these two numbers, 4x and negative 12. Does anybody know what the greatest common factor between those two terms are? 4. So I can take a 4 and an x minus, not x minus 12. X minus what? Nope. What's 12 divided by 4? 3. Good. So when we take the 4 out, because 4 is the greatest common factor, I'm doing like reverse distributive property. Right? If I wanted to simplify this, I'd distribute, wouldn't I? And get 4x minus 12. So I'm doing like the reverse distributive property. So distributive is multiplication, so that means the reverse of it is divide. So to take out that GCF, I'm dividing this by 4, which gives me 1x. I'm dividing this by 4, which gives me negative 3. Does that make sense, guys? Okay. What's the GCF here? 5. Right? Divide this by 5. What do we get? Divide this by 5. What do we get? X, right? So we have 5 times x. Divide this by 5. 10. You have now... Oh, that was a squared on your note. Sorry about that. That is common term factoring. You're pulling out a common term. It's easy? Good. Never mind. No? Don't worry. I'm not going to change our next course. Okay. 3x squared minus 2x. Common factor, what is it? 1. X. 1x, right? So if I take an x out, this becomes 3x. Good. This becomes negative 2. You don't get that one? Okay. If I divide this by x, it cancels out the squared, right? This is 3x. Oh, yeah. If I divide this by x, it cancels the x. So just like 2.
It's just like, wait. Oh, okay.
It's exactly reverse distributive property. Backwards distributive property. However you want to say it.
Wait, wouldn't it be 2x?
Nope.
Because we're dividing it by 1x.
Right.
1x.
2x divide x.
Oh, okay, right.
Those cancel.
Oh.
Right? So you just got 2. Okay. And I can't pull a number out because there's no common number here except for 1. Right? Does that make sense? Okay. Now, I'm moving onward. IV. 3x squared minus 18x plus 27. Now, you had one like this on your homework. Did anybody try to use the box method for this? Did it work, Bruno? It did? You got the right answer? Okay, you could box it, but it didn't give you the answer I had in my answer. He did it. Okay. The reason why is because you're multiplying the A and the C, if you don't take out a greatest common factor, now your A times C will have the greatest common factor squared in it. It really messes things up. Okay? So what you need to know, this is something we need to add, not just to an A is not 1, we also need to add this. Take a look at the 3 numbers. Is there a greatest common factor? 3. Typically, if there's a greatest common factor, it makes this a lot easier, Joanna. All right? Then it becomes a very easy problem. Because a lot of times when you take out the greatest common factor, what happens to your A value? It goes to 1. And when A is 1, this is easy, isn't it? Okay. So let's take out a greatest common factor. So Whitney said it's 3. So divide this by 3, what do I get? X squared. Divide this by 3, what do I get? Good. Divide this by 3, what do I get? 9. So we took out the greatest common factor of 3. What happened to our A value? It became 1, right? So now the 3 kind of hangs out and watches, and we factor x squared minus 6x plus 9. Right? So what do I do? What times what? Okay, 1 times 9, good. Equals 9. Factors of 9. Okay, negative 1 and negative 9, right? Because we have a negative 6 right here. Because we have a negative 6 right here, right? We want the negative factors of 9. Because if I add positives, I won't get a negative, will I? So I got to add negative numbers together. Okay? So negative 1, negative 9. Okay. Which ones add to negative 6? Negative 3 and negative 3. 9, you okay? Okay, pick it up, please, then. So that means I can rewrite this as x squared minus 3x plus 9. Right, does that make sense, guys? Yeah? And the box. Look, I need to get out the gloves every time I say that. Alright, x squared minus 3x, 9. Can we factor this? Yeah, okay, take 2 minutes here and factor it. Alright, so what are the factors? What goes here? X. Okay, so that means this factor was x minus 3, right? Right? Can't forget that, guys. So where does that one go? In front. Right? Yep. So 3 times x minus 3 squared. Perfect. Does that make sense? Does that make sense, guys? Yeah. I'll change it, please. Because the other ones weren't trinomials; they were binomials, and they couldn't factor. Now there are some ones that'll be hiding that'll look like binomials, but they're really trinomials. But let's say I have something that's like x squared minus 64. Remember we factored this one before? Does anybody remember that factored into? There's the 2 8s. There's x minus 8 and x plus 8. So you have x squared minus a perfect square. Then that's a trinomial hiding as a binomial. Okay? So perfect squares are like 4, 9, 16, 25, 36, 49. Okay? The number is all squared. Right? Okay, does that make sense, guys? So that one's hiding as a trinomial. Now, if it was this, that's just a binomial. Okay? That's not a trinomial, that's just a binomial. 2 terms. If I have a minus 64, then that means we're hiding a 0x. Because the 2 8s cancel each other out, right? But if it's a plus 64, then the 8s won't cancel each other out, it'd be 16x. Alright, so if you have x squared minus a perfect square, that's a trinomial that's hiding on you. Alright, let's try v. Now I know that some of you are going to forget to factor out the GCF. Right? Serena, anything that's possible? Okay, yes. I think that's what she's saying. Said, Serena, do you think that's possible? She just woke up. Okay, so let's say I forget to factor out the GCF. What's our first step then? What would we do? And don't write this down, please. Don't write this down. Okay, because I don't want you to mess up your notes.
Take out
No, let's say we forget that part.
Oh.
We just say, oh, trinomial, let's factor, let's go.
Multiply
2 times negative 32. Negative 64, right?
Would we still get the same answer?
That's what I'm showing you right now.
Oh.
Okay? So negative 64. What are the factors? We have negative 1 and 64, negative 64 and 1, right? We can list them all. Okay, I'm going to zip to the end because I know the answer already. Negative 4 and 12, negative 12 and 4. Which one should we use? Oh, sorry, not 4 and 12. This is 16. 16. There we go. Which one should we use? Okay, good. Negative 16 and 4. Right? So I can rewrite this as 2x squared minus 16x plus 4x minus 32, right? Right? Does that make sense? Okay. Now we box. 2x squared minus 16x, 4x minus 32. Can we find the greatest common factors? What's the greatest common factor here? 2x. What about here? Okay. What about here? 2x. What about here? Negative 16, right? Now, do you guys remember the check I just told you about? Where the columns overlap, we should get the product of those two, right? 2x times 2x, what does that equal? Is that right? No. 2x times negative 16x. Is that right? No. 2x times 4 makes 8x. Is that right? 4 times negative 16. Negative 64. All of my numbers were bigger by a factor of 2. Because I didn't pull a 2 out when I got started. Does that make sense? So,
wait, how do you check it again?
okay. I see where these overlap. Okay? So 2 times 2 should be
Okay,
4, and I got 2x, didn't I? Right? 2 times negative 16 should be negative 32x. I got negative 16. Right? Same thing here, we got 8x, and here we got negative 64. So all the numbers are too small, right? Or too big. All my products are too big, aren't they? They're big by a factor of 2, because I didn't pull a 2 out. So if that happens, what should you do? And this is why I told you not to write it down. Okay? Because we need to start over. And we need to factor out a 2. So factor out a 2. Right? Oh my goodness, I didn't factor 2 out right. Way to go. Epic fail. Okay. 12 divided by 2 is 6. 32 divided by 2 is 16. I'm glad you guys can do math. All right. So now, I made the problem really easy, didn't I? Because now A is 1. Okay. So 1 times negative 16. What do we get? Negative 16. Factors of negative 16 are 1 and negative 16. Negative 1 and 16. Any other ones?
3, 4.
Negative 4 and 4. Negative 2, 8. Negative 8, 2, right? Right? Which ones add to negative 6? Negative 2, 8. So I can rewrite this right here as x squared minus 8x plus 2x minus 16.
Well, you said negative 2.
Negative 8, 2. Sorry, my fault. Okay. And I need to add a negative 6. I'm sorry. Thanks for catching me. Me? Oh. Otherwise, you wouldn't be the first one to express that sentiment. You wouldn't be the first one to express that sentiment. All right. So now you GCF, right? What's the GCF here? X. GCF here. 2. GCF here. X. GCF here. -8. Now if we overlap our columns to check, x squared, -8. Right? Works out. 2x, -16. Works out. We're good. Okay. So x plus 2, thank you. X minus 8. This 2 is hanging out. Where does it go?
In the front.
In front. Okay. And that would be our answer. Okay. Does that make sense? Okay. Take a look at the last one. While I erase the board, take a look at the last one. I want you to see if you can find a GCF. Don't shout it up though. Just look. Hey, why are you talking? Because I'm talking.
You were talking. You were erasing.
All right, I was erasing. Stipulation, details, semantics, whatever you want to say. I laugh. Is there a GCF?
Yeah.
What is it?
9.
9. So if I take a 9 out, look at this. There you go, Mr. Branch, you got that one right.
Woo!
So now I multiply A and C. Thank you, Faith. Now I multiply A and C, right? So 1 times 2 is 2. Man, it's easy when I factor out that A. Okay. Factors of 2 are...
But you can't.
Okay.
What?
Do any of these add to 1? No. So guess what my answer is?
Non-factorable, buddy. Oh.
That's my answer. Okay. That's factored. All right. Are there any questions?